Good morning, everyone. Our topic for today is the images formed by curved mirrors, specifically the convex mirror. This is a presentation by yours truly, your teacher in science, Mrs. Maricel M. de la Cruz. Our main objectives are the following. First, determine the location and size of the images formed by curved mirrors using ray diagrams. Next, we have to draw a ray diagram to determine the image produced by diverging or convex mirror. We will distinguish between real and virtual images, and we will try to appreciate the use of convex mirrors in our daily lives. Okay, so everyone look at this one. Let us try to spot the difference. Look at the image form. The first one is the image of a man, and the second one is an image of a hand. Can you spot the difference? What can you say about the first image? What can you say about the second image? In the first image, you would be able to see the reflection of a man as it is, merely showing that the size of the man is the same size as the image. But look at the second image. Can you see the hand? What can you say about the hand of a woman? The hands are too small to compare with the reflection. The reflected image has a bigger hand. Okay, let us try reviewing our previous lesson, the plane mirror image characteristics. Look at your twin. Have you seen your twin? Okay, if you want to see your twin, just look at on a plane mirror. Your image and you are identical. If you are looking at a plane mirror, you will have the same distance. You have an orientation of upright image. You have the same size and a virtual image, reversing it to the left. The next one, the concave mirror image characteristics. In concave mirror, it's somewhat complicated since it is a converging mirror. So I am using the numbers 1 to 9, and the blue colors will be the image. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 object located at different position. And you will have the image, the blue one, that are also located at different position. In concave mirror, it's quite complicated because at a certain position, the images changes its height, changes its orientation, and apparently could be diminished. Okay, in that case, we can now compare the characteristics of concave mirror with the one of the convex mirror. Now, may I ask you, would you like to become sexy in just a snap? Is it difficult to become sexy in just a snap? Okay, we can do that in just a blink of an eye. But how? How can we be sexy in just a snap? Do you want to become this image? Would you like to become sexy as this woman in the picture? That is not impossible with the use of convex mirror. Okay, look at the given pictures. The first one and the second picture. The first picture, most probably you have seen that already in different stores, in different convenience stores. And the second picture is a rear view mirror from a car. What have you noticed? Have you noticed those materials that are present inside the store are reflected, or there's an image reflection of a smaller one? Okay, let's have a deeper understanding with that. Okay, a concave mirror and a convex mirror are different in features. The convex mirror is considered as diverging mirror, and the concave mirror in your previous lesson is considered as converging mirror. The difference is that, as you can see in convex mirror, you will be able to see the wider view, or the materials, the objects that are present in front of the mirror become smaller. While in the concave mirror, the image that is small, it becomes bigger. But that doesn't happen all the time. It depends on the location. Okay, so let us proceed with our lesson. Okay, let us now go back and try to understand what really an image, what type of image formed in a convex mirror. As you can see, in an example of ray diagram, there are only two rays that we will be focusing. The first ray that will hit the mirror, okay, this ray, will be reflected back. And that reflection, we will be tracing back. We will be forming an imaginary line at the back of the mirror that will actually hit the focus. There are different rays of light, or there are a lot of rays of light that we will be focusing only on the two rays, which we can already have an image. Okay. The next ray of light, this ray of light that will hit the center of the mirror and will be reflected parallel to the principal axis. Again, we will be tracing that backwards, so that we would be able to see and be able to form an image. Okay. The first ray that is reflected to the focus, and the second ray that is actually reflected parallel to the principal axis. You can see that there is an intersection of the imaginary line that we form following the reflected light. And there we can see the formed image. We will try to locate the object at different position. Here at this position, and the other one nearer to the mirror. So from very far to the mirror, which is the first one, and the next one, as it gets closer to the mirror, and the closest to the mirror. What have we noticed about the image form? Remember when we tried to focus on the acronym LOST? Okay, let us try to go back with the acronym LOST, where L stands for the location of the image, O as the orientation of the image, S as the size of the image, and T as the type of the image. As you can see, the images formed in a convex mirror to whatever position or location of the object is, the image is always located behind the convex mirror. An upright image, a reduced in size smaller than the object, and the virtual image. Okay, let us try to look at this picture. You can see the numbers 1 to 7. Okay, that's 1 to 7, the red color. These are the objects in front of a mirror. And at the back of the mirror are the images formed in accordance with the location of the object. So as you can see, we're going to sum it up. All the objects, to whatever location they will be positioned, they will never form an image that is bigger than the object. The object is always bigger than the image. The orientation of the image is upright, and it is always smaller than the object. They are virtual because they are formed behind the mirror. Okay, let us try to look at the picture and let us try to analyze how these pictures are used in our daily lives. These are types of convex mirror. Large offices, stores, and hospitals use convex mirror to let people see around the corner so that they can avoid running into each other and prevent any collision. The next picture used in sunglasses. This picture will actually help us. Most commonly uses of convex mirror is for making sunglasses. The convex mirror reflects the sunlight away from the person's eye wearing the sunglasses. Okay, a convex mirror used in vehicles for rear view mirror. Convex mirrors are widely used as rear view mirrors in automobiles and vehicles because it can diverge light beams and make virtual images. The next one, a convex mirror used for security purposes. Convex mirrors are also used in various places. There are places near ATM so that the bank customer can check if someone is behind them. For our assessment, we will draw a ray diagram for a convex mirror, and we will describe images produced by a convex mirror. I am giving you the freedom on where do you want to locate your object in front of a convex mirror. And you have to use a ray diagram to form an image. On what type of image will be formed, you have to understand that you have to fill out our acronym LOST. Describe the image produced by a convex mirror, of course, with the use also of our acronym LOST. Okay, everyone, to encapsulate our lesson, I would like to leave to you the message of this sad guru who really has connection with our previous lesson. Let us not forget that our mind is like a mirror. A concave mirror exaggerates. A convex mirror depreciates. And a plane mirror shows you life the way it is. Now it's your choice to what type of mirror you're going to use. Is it the concave, the convex, or the plane mirror?